can you see the mechanism? When I try to use a force, or try to use a moment to turn this link, you will push this link upwards, correct? So that this piston will be pushed up as well. So I need a force to counter this force, from the bottom. Okay. So that's why this P is P here. Okay. So the question is, what's the P here to counter this moment? Okay. Start with. Any other questions about this one? Okay. Apply our standard operating procedure. Okay. The first step is to look at how many objects do we have in this system. So in this question, how many objects do we have? What are the objects?
A, B, B, C.
A, B,
B, C.
B, C, and
Slider.
the slider. Correct. So for these three members, the second step, what do we need to do? Second step. Yes, free body diagram of this tree. Okay. If you do not have experience in looking straightforward for the conclusion, you need to do the free body diagram for all of them. Okay. So let's solve them one by one. Okay. For the upper part of this for this slider, what are the forces is experienced? P, of course. What are the point of contact? Sorry? The what force?
Normal force.
Normal force from where?
From the wall.
From the wall, correct. Maybe in this direction, maybe in the other direction, we don't know. Okay, we just assume it is in one direction. In the end, we find it's negative, means it's in another direction. So here, we can just assume it's along a line, but without specifying which direction it is. So what are the other forces? Are there any other forces? From the BC, correct? So from the BC, what's the direction of this force? Along the BC axis, why?
Two force member.
Two force member, correct. Two force member without any force in between, without any external moment. Okay. So in this condition, that we can get immediately clue that this force from this BC will be in the axial direction. So we know its direction immediately. So this is a free body diagram of the first object. For the second, actually we don't need to analyze so much because straightforward we know that the force is all inside this axis. So since it gives a force to this piston of this direction, this slider gives it another counter force of this direction. And in other words, because it maintains static equilibrium, there will be a force from BA in axial direction as well. Okay. And of the magnitude same as this one. Same as this one. Okay, same as this one. Okay. So the third object, this BA, what are the forces experienced and what are the directions for BA? Any clues? Any guess? First one is the moment here, correct? Moment you can consider as a special type of force. Okay. Moment equals to force times the force R. Actually, the unit should be Newton times meter. Okay. So here, 1m in this direction. What are the other forces? What are the point of contacts? You might give me any forces.
B.
Sorry?
B.
Say it loud.
Point B.
Point B, okay. What direction?
Along the BC.
Along the axis of BC, correct. Because it's a reaction of the force here, correct. Means this member give BC a force here. So definitely this member will give it a counter force here, which is according to the Newton's third law will be in the opposite direction of same magnitude here. Okay. So are there any possible forces? Any possible forces? Any other possible forces?
Reaction force.
Point A.
Point A, correct. So these are the only 3 points of contact. Okay. Point A. Direction?
How long is
We don't know. Yes. We don't know, and we probably don't care. Because here again, we need to use moment analysis, correct? So we take this moment of this A, okay? So we choose it as a point analysis. Look at this number. There are only 2 moments inside this number, okay, with respect to this point A, okay. One is in this direction, the other moment is in this counterclockwise direction. So through this, use that sigma m equals to 0. Then we can find that because the moment here, which is in the clockwise direction, okay. For clockwise direction, we normally use a negative sign. This is a sign convention. Counterclockwise moment, we use a positive. Clockwise, we use a negative. Okay. This is a sign convention, a standard. Plus what? What is another moment created here? What is another moment created here? It's caused by this force, right? Correct? This force B. Fb times its force arm. What's its force arm? What's the force arm of force B?
60.
Again?
60.
Sorry?
60.
This one, right? From the point analysis, the distance from point analysis to the force, to the extension line of the force. Okay. So this is the force arm that you are looking at. How to find this from this diagram? There's some simple geometry again. Hopefully you know how to solve this geometry problem. Okay. Just to find the angle of this one, or either this one, because this one is the 90 degree. Okay. This one you can find from the angle here and here. Then use 180 to minus this angle, then you get a theta. This angle is a bit tedious to can be calculated from this one and this one. And this one angle can be calculated from this 80 divided by this 60. It's tangential value. Okay. So this calculating part I won't go through with you again. I assume that you know this geometry or knowledge. Okay. But if you don't know, you come and approach me later, or you can just ask me now. I will go through it with you. Don't worry. Okay. So here, after this, times its force arm, Fb times its force arm. Okay. Assume it's d something, but this definitely is a constant we can find. Okay. This is a number equals to 0. This is summation of force of movement equals to 0. Because why? This one is in a counterclockwise direction. So this one should be positive. And this moment is in a clockwise direction, so we should use minus. Okay. So this is a sign convention. So in the end, we sum up all the moment together, we will get our 0. Okay? So here, after analyzing this one, minus m is given in the question, minus 1,500 Newton meter, correct? And this b is also calculated from this geometry. Then you can get your FB here, correct? After you get in your FB here, as we analyze for the second number, okay, FB, here's a counter force here. So this one, this force FB equals to FC here. FC again equals to this one. Still remember the reasoning, Newton's third law, okay? Reaction and the counter reaction. these are all reaction of counter-reaction. Okay. So actually, your FB find here will be equivalent to the FC over here. Yes.
Can stop.
Okay, sure.